Today I would like to present our mini project, which is a mini atomizer that by using a handheld bicycle pump. Okay, this project is used to generate the air jet that produced by the bicycle pump, and a soda can as a water reservoir, and a straw as a tube. The T tube that we join together, which have two types on the T tube, which are made from straw. Then in this project, we want to investigate what will happen to the water in the soda can. We have used various types of method or item in this project, which is we use a different diameter for the two straw. The method we use is different speed for the bicycle pump. We use different speed for the bicycle pump to produce different velocity during the air inlet through the straw, so we can know what will happen to the water in the soda can after different pressure is applied.
Today I will be present about literature review on our project on fluid dynamics. So first of all, what in this project, what concept of fluid dynamics that we can study? So the answer is Bernoulli principle. So in the simple term, Bernoulli principle is term that speed of fluid will increase and the pressure will decrease. So that is the simple term of Bernoulli principle. That can be proved in the article that from the Britannica, written by Gloria Lotta in 2017. The article says that if the fluid flow through horizontal pipes with cross area, for example, the smaller the area, the bigger the pressure. It means when you have the small diameter, the pressure will be bigger. Okay, so the other example that can be related to our project is the article from Science Direct. Science Direct written by Fatima Baipa in 2018. The article says a decreased pipe diameter will increase the velocity and kinetic energy. So that is the concept that we can say about our project. In our project, the results say when the diameter of the atomizer or the straw is smaller, and the pressure will be faster or increase. So, and lastly, our formula will be take from the theory that come at the Bernoulli principle. So, thank you.
In this video, I'm gonna to explain about the equipment that I will use to doing my project prototype, which is mini atomizer by using handheld bicycle pump. Okay, let's straight to the point. The first equipment that we are using in this prototype project, and this is the most important equipment that we need to use, which is the handheld bicycle pump with air pressure meter. This for the next equipment that I will use during our prototype project is straw. From this straw, I will make two sample of tube that we will use to run our prototype. Okay, here for the first sample, we have a 7 diameter and for the length is 97 and for the height here is we have 101 For the second sample, come up with 10 diameter, the length is here 123 and for the height is 70 Okay, for the third equipment that I will use in this prototype is masking tape. The purpose of this masking tape is I will make a joint in this tube, which is the pit tube. Okay, you can see the two samples here. I will fit them with masking tape. For the last equipment that we are used is under plastic. Okay, for the next video, I would like to show you how I handle the prototype testing experiment. For that testing, we can prove that the Bernoulli principle are true or not based on our project. Thank you.
This experiment is about Bernoulli principle. In Bernoulli principle, it is stated that an increase in speed of fluid occurs simultaneously with decrease in static pressure or a decrease in fluid potential energy. So when we use a straw, how do we suck the fluid from a cup? We are keeping a pressure inside the straw lower than atmospheric pressure. By doing this, the water will go from high pressure to lower pressure. Same as this atomizer, when we blow high velocity air inside the upper T straw, we create a low pressure in there because of high velocity. Assume that P2 is same as atmospheric pressure and P1 is smaller than P2. We can use Bernoulli principle, and then we can ignore air density because air density is very small. Different in fuel height will make no change, so we can ignore this one and this one. Let's assume that the velocity assume that air velocity inside the can is stationary, so we can assume that V2 is 0. So then we get the equation like this. So we calculate using this equation and we get the difference between P2 and P1 is 33.57 kilopascal, and then we get P2 67.73 kilopascal. So this we have shown that P2 is lower than P1. P1 is atmospheric pressure. Okay, so using the different pressure, we can get force. Now we can calculate how many pressure pushing the water out using the formula F equal to PA. And then we get force is 1.29 Newton. So then we can calculate how much pressure needed for the water to go out the straw. So using the formula pressure air equal to rho water GH, we get that pressure that needed is 147.15 pascal. Then we convert it to force, then we got 0.006 Newton. Okay, since the force for the water to go up the straw is 0.06 Newton and the force created in straw is 1.29 Newton, which is higher than the water will surely go up.
In conclusion, we can conclude that this mini project is related with the Bernoulli principle. We use various kind of method which are shortened in length of the straw. Another one is the diameter of the straw is small, and the last one is the high speed during pump. These three methods we use is lead to the high in velocity. In Bernoulli principle stated that when the velocity is high, the pressure will become decreased, so that during this project, when the high speed during pumping, it will lead to a high velocity, so that at that part will become low in pressure. Atmospheric pressure will become high and push the water in the soda can go through into the straw and burst out. So by building this mini project, we have proved the theory. Thank you.